Hi, friends. Today we are going to be looking at the solution for some of the questions we were given as a take home in our previous exposition on getting the distance of bodies traveled in the end time. In our previous lesson, we did a very good job on how to get the distance traveled by bodies in the end time. Please, if you've not seen that very lesson, just take a break and go see that lesson in order for you to understand what we're about to take right now. So this was the very first question we were given as a take home. An object was thrown into the air with a speed of 30 meters per second. What distance would it cover in the third second? Now, don't forget that we treated two things, which was distance covered by bodies in the end time for bodies along y-axis and for bodies along x-axis. Now, for bodies along x-axis, we are given a major formula. This was the formula we are given. We are given this distance traveled by bodies along x-axis. We said u, that's initial velocity of the bodies, plus acceleration over 2, open your bracket, 2n minus 1. Now don't forget that the n represents time in seconds. That's what we said in our previous lesson. Now this is for bodies along x-axis. Now for bodies along y-axis, two formulas were given for bodies along y-axis. For bodies traveling along y-axis, it is u, initial velocity, plus distance around gravity over 2 times 2n minus 1. And this formula was also given. This is for bodies along y-axis. What kind of y-axis is this? This is for falling bodies. For bodies that are falling along y-axis. And also, we gave this formula was derived. Then that's this also for bodies along y-axis, u plus u over 2. Then 1 minus 2n, which is for bodies that are rising. This one is for bodies that are rising against gravity, unlike for falling bodies. These bodies are disobeying gravity. And also, we also gave a formula. This is a general formula for everyone, a strange one. It's simply the final velocity plus initial velocity over 2. There's no time actually. Just final plus initial over 2, just an average velocity. Now, all these formulas or all this formula were given in our previous, exposition. So, what are we going to do if an object was thrown into the air with a speed of 30 meters per second? What distance will it cover in the third second? Now, don't forget, this is the best. This is the formula we're going to use here. This very third one. Don't forget the body was rising against gravity, and that's it. So you saw acceleration of bodies along y-axis. So what are we going to do? So how do we get the distance the body covered in the third second? Don't forget the n is 3 because that's what we're talking about. That's the distance covered by the body in the third second. Gravity is 10 meters per second squared. Don't forget this is supposed to be minus gravity, but this is a formula already derived. Everything has already been fashioned in. So how do we get this? How do we get the distance covered by the body in the third second? That will be s third second. We're using the third formula here. This is what we are using. Initial speed already has been given as 30 meters per second. So what do we have? That's 30 meters per second plus gravity, which is 10 meters per second squared over 2. Then 1 minus 2 times, what do we have? That is the third second, 2 times 3. So what do we have? So distance traveled in the third second is 30 plus 2 year 1, 2 year 5. So we have here 5. 1 minus 2 times 3 is 6. So what do we have next? Distance traveled by this body in the third second would be with this, that's 30 plus 5. 1 minus 6 is minus 5. 30 plus and minus is minus. 30 minus 25 will give us 5 meters. So the body covered a distance of 5 meters in the third second. So if you really want to save yourself, the stress of getting the distance traveled after 2 seconds and 3 seconds, that's the best formula to use, as simple as ABC. Question 2. This was the second question we were given as a take-home. A fruit falls from the top of a tree and traveled 10 meters in the last second. What velocity did they hit the ground with? Now, don't forget, a question like this was treated, in our previous lesson. We took one of a question that looks like this as a worked example. So, how do we get the final velocity, which is the velocity the fruit hits the ground with? Now, don't forget, a fruit falls. Now, for the fact that a fruit falls, it simply means that the fruit was probably at rest, or surely at rest, before it dropped out of the tree. So, now don't forget, this is for bodies accelerating along y-axis. As you can see, it's very clear. So we have a major formula we're going to use there. we're going to use this formula right up there. That's S nt equal to U plus G over 2, open bracket 2n minus 1. This formula is a formula that is the best formula for falling bodies. So don't forget initial speed first is going to be, initial speed is 0 meter per second. So let's write out our formula. Distance traveled by the body in the n time is U plus gravity over 2, 2n minus 1. This is for falling bodies. This is for bodies whose gravity is plus 10 meter per second squared. So don't forget, they didn't tell us the time, the time it took the body to fall. It wasn't mentioned. It didn't tell us if the body covered this distance in the 4th second, in the 5th second. They didn't tell us the second, but they just told us that 10 meter was covered by this body in the last second, but the second was not mentioned. So we're going to try to look for a way to get the second, at which this body covered this very meter, which is 10 meter. So this time the end time already is given. The distance covered in the end time is 10 meter. It's already stated. So the time is not given. We don't know, but we know gravity is. Gravity is 10 meter per second squared. It's already stated. Initial speed is already given right here. So first of all, we're going to get the n, which is the time it took the body to cover this very distance. So we're going to see if it's going to be in the 4th second, the 5th second, the 10th second. We don't know what it is right away, but we can get to know right now. So this SNT, which is 10 meter, the initial speed is 0 meter per second. Then plus, the gravity is always 10 over 2. Then 2n, which is what we're looking for. We're looking for the n, minus 1. So 2 year 1, 2 year 5. So what have you? This is just gone already. So this 10 equals to 5. Open your bracket, 2n minus 1. So what are we doing next? The next thing we're going to do, we're going to divide both sides by 5. Like this. So 5 here 1, 5 here 2. So 2 equals to 2n minus 1. As simple as this. You're going to get, you're going to collect your like terms. You know how to do that. So 2 plus 1. This crosses over to this place. Equals to 2n. So 2 plus 1 is 3 equals to 2n. Divide both sides by 2. So n is 3 over 2, which is 1 over 2, or 1.5 seconds. So it was in the 1.5 second that the body covered the 10 meter distance we're talking about. So we've gotten our n already. So we're not done yet. We are asked to get the velocity that the body hit the ground with. So don't forget, we have the initial speed already, which is 0 meter per second. We have the time it took the body to cover that very 10 meter, so we have 1.5 seconds. So we're going to get the final velocity. So the final velocity is what we don't know, and we're going to get to know that now. So we have the time, 1.5. We have the initial speed. We have the, acceleration. Don't forget that the body dropped, the foot dropped. So acceleration here along y-axis, which is gravity, is plus gravity. The body dropped is the big gravity. That's plus 10 meters per second squared. So what is now the final velocity? We're going to use this v equal to u plus at. This is what we're going to use, v equal to u plus at. So what do we do next? Simple. That's what we're going to do next. So the final velocity is initial speed, 0 meter per second, plus acceleration, 10 meter per second squared, times time. The time is 1.5 seconds. So the final velocity is 0 meter per second. 10 times this will give us 15 seconds. So meter per second means 15 meter per second, I beg your pardon. So seconds cancel seconds, so cancel the seconds, so you have second there. So that's 15 meter per second. So final velocity is 15 meter per second. So this was the speed the body hit, the fruit hit the ground with. As simple as that. Okay, question 3. This question was a third and final question we were given as a taker in our previous lesson. Now, we are asked to get the distance covered by the body in the 5th second if a car took off with a speed of 8 meters per second and ended the journey with a speed of 7 meters per second. Now, how do we get the distance covered by this body in the 5th second, provided the body took off with a speed of 8 meters per second and ended the very journey with a speed of 7 meters per second? Now, that's a major formula, a very fundamental formula. Now, this very formula probably discards the time, regardless of the kind of time it took the body to cover such a given second. And here's a formula. So yes, it's a distance traveled by body in this n time is final velocity plus initial velocity over 2, which is simply average velocity. just have to get the average velocity, regardless of the time, either 10 second, a million second, whatever kind of a second it is. You know, you just have to get the average velocity to get the distance traveled by that very body in that very given time. So here's it. So distance traveled by the body in the fifth second is final velocity. Final velocity is 7 meters per second. Initial velocity is 8 meters per second. The time is 5. That's 5 seconds. That's the fifth second. That's 5. But we're not going to be using it based on this formula. So what's the final velocity? 7 meters per second plus initial velocity 8 meters per second. We're simply getting the average velocity. That's all. So distance in the fifth second is 15 meters per second divided by 2. We end up with 7.5 meters. So the body covers 7.5 meters in the fifth second. Now it's going to cover the same 7.5 meter in the 10th second. As simple as that. So at the very point in time, if you got all this assignment, all those questions, if you got them right, it means you understood what we took in our previous lesson on distance traveled by body in the end time. So we're going to be drawing the curtain on today's lesson at this very point. If you found this lesson very resourceful, please subscribe to this very channel and share this lesson with others. See you in the next lesson. Thanks.